Let's talk about polar reagent addition. So, polar reagent addition, as the name suggests, ay pagdagdag ng isang polar reagent. So, we can see here the simple illustration ng isang double bond. So, we know that double bonds have one sigma and one pi bond always. So, yung pi bond in a polar reagent addition, nagbe-break to. So, this pi bond will break and this will break to form new sigma bonds sa new compound. So, let's discuss it further in this video. So, we have 3 types of polar reagents. Technically, 4 sila here, but I'll discuss later why it's only technically 3 polar reagents. So, first we have addition of water or hydration. We can see that hydrogen is the more electropositive side of the reagent, and OH or hydroxide is the more electronegative side. And we know them as these ions separately, right? So, mayroong mas positive, mayroong mas negative. And kung titignan mo siya na mabuti, this is actually just a water molecule. Ayan. So, next we also have halogenation. Alam na natin to, common sense halogenation, pagdagdag ng isang halogen. So, they just arranged it into more electropositive and electronegative parts. We also have acid addition. If you will recognize this formula right here, this is actually H2SO4, which we commonly know as sulfuric acid. So again, they just separated it into a positive and a negative part. Okay, so let's talk about the steps of polar reagent addition. So we have 2 actually. Electrophilic addition and nucleophilic addition. So to understand these better, i-define muna natin kung ano ang isang electrophile at isang nucleophile. So electrophiles are electron deficient. Kulang sila sa electrons. So naghahanap sila ng electrons. They are desperate for electrons. They love them. So they are called electrophiles, lover of electrons. And then nucleophiles naman are electron rich, or in other terms, electron donating. Okay, so these ones, nucleophiles, love a partially positive nucleus. So, ayun, yun yung basic definitions nila. So, in electrophilic addition, as we can see here, the 2 carbons in the double bond, yung isa dun ay nagiging carbocation. And later, we'll discuss the importance of the carbocation in Markovnikov's rule. But for now, ito muna yung basic structure ng isang electrophilic addition. Napupunta yung carbocation on one side, and then on one side naman ay na-add yung electropositive ion without the positivity na. Okay? So sa nucleophilic naman, this is a prerequisite to this. So kailangan munang mangyari itong electrophilic bago tayo mag-move on sa nucleophilic pagdating sa mga polar reagent reaction. Okay? So again, simple explanations lang muna. We'll go into detail later. So yung nucleophile will be attracted. Since nucleophile attracted sa positive, mapupunta siya here and it will bond to form our new product. Okay, so let's discuss how this works in our different types of polar reagent additions. Let's start by discussing the addition of water or hydration. So, again, in polar reagent additions, we divide it into 2 parts. May electrophilic addition and may nucleophilic addition. So, for now, unahin natin yung ating electrophilic addition. So, this would be our electrophile. Itong H. Okay. So, as we know, it will break the double bond. Itong pi bond sa double bond will break. And itong sigma bond between our reagent will also break to form the new compound. Pero, let's break it down step by step muna. Okay? So, first, magkakaroon tayo ng carbocation. For now, since these are both terminal, pareho silang nasa dulo, let's just pick one to be the carbocation and let's just pick one na makakabitan nung hydrogen. Okay? So, random assignment muna. So, in this case, itong nasa kanan na carbon yung pinili ko to be the carbocation. Now, meron na tayong carbocation na add na din natin si H. So, si hydroxide naman. Okay? So, let's now add our nucleophile. OH. So, naturally, since this is negative, magiging attracted siya dito sa positive, sa carbocation natin. So, doon siya magbabond. Alright? Let's illustrate that here. So, this would be a regio isomer of the reaction, of the hydration reaction that just happened. So, if we name this, it would be named 1-ethanol, if I'm not mistaken. So, sabi sa Markovnikov's rule, when an unsymmetric reagent bonds with an unsymmetric alkene, the electropositive, the more positive part of the reagent bonds to the carbon with more hydrogen atoms in the double bond. So let's explain this further. We have what we call unsymmetric reagents. These are polar reagents that we discussed earlier. These should look familiar by now since we discussed them kanina at the start of this video. So, an unsymmetric reagent and an unsymmetric alkene, kapag pinagsama mo sila, Markovnikov's rule is applicable. So, let's try to look at the explanation. Why does Markovnikov's rule happen? Alright? So, there are two factors that confirm Markovnikov's rule. First is the number of hydrogens and the classification of the carbocation. Alright, so let's look at them. Down here, we can see a diagram for the least stable and most stable carbocations. So this is called a primary carbocation. Then this is secondary and this is tertiary. And yung classification of carbons is determined by how many alkyl groups or R groups ang nakakonect sa kanila. So, sa primary carbon, isang R lang. Sa secondary, dalawa. Sa tertiary, tatlo. And if you will also notice, as we go further down the classification of carbons, paunti rin ng paunti yung count ng hydrogens. So, following Markovnikov's rule, we know na yung electropositive na part nung polar reagent ay kumakabit sa carbocation with the least amount, with the most amount of methyl. Therefore, mas kumakabit siya sa mas mababang type of carbocation. So, if you were to have H+, it's more likely to bond with a primary carbon rather than a tertiary carbon. Why? Because mas maraming hydrogens dito kaysa dito. Dito dalawa hydrogen, dito isa lang. So, mas likely kumonect dito si H+. Okay? So, yun yung logic when explaining in terms of number of hydrogens. Pag naman in terms of classification of carbon, ayan, most stable. So, ang kumakabit dito sa most stable na carbocation ay ang ating electronegative naman. So, in this case, OH. mas likely siyang kumabit doon sa mas stable na carbocation. Okay? So kasi, merong iba't ibang isomers sa Markovnikov's rule. We call them regioisomers. Sa regiospecific, isang product lang yung lumalabas sa reaction. Sa regioselective, mainly one product. So, ibig sabihin, dalawa pa ring products yung lumalabas, pero yung isa doon ay mas favorable. Okay? So, let's analyze yung hydration reaction ng propene in terms of Markovnikov's rule. So, as we can see here, may nangyaring electrophilic addition, right? And as explained in Markovnikov's rule, mas likely na kumabit yung electrophile sa carbon na mas maraming hydrogen. Alright? So, pag tinignan natin yung double bond here, ito yung alkene. Pwedeng maging carbocation, either one of those. Pero, kakabit yung electrophile yung electropositive na element doon sa mas maraming hydrogen, which is this. Kasi 2 versus 1, syempre, mas marami si 2. So, dito yung correct na pagkabit ng H. Okay? So, we can confirm that here. Diyan siya kumabit. And then, sinabi rin natin kanina na pwede tayong mag-analyze ng Markovnikov's rule based on the classification of carbon. So, the higher the classification of carbon, doon kakabit yung ating electronegative na atom or polyatom. Right? So, in this case, yung OH, sorry, mali pala yung sign. This is supposed to be negative. Ayan, this is our nucleophile. Negative. Ganito. Electronegative siya. So, mas kakabit siya doon sa carbocation na mas mataas ang classification. So, of course, mas mataas ang classification ng secondary carbon. So, we can deduce na this regioisomer, this regiospecific isomer, ang lalabas sa hydration reaction ng propene. Okay? So, let's go back at that kasi medyo nakakalito siya. So, in terms of hydrogen, number of hydrogen, doon ko connect ang ating electropositive. So, doon siya kumonect sa CH2. Kumonect siya sa CH2. Okay? And then, sa classification of carbon, this carbocation, this is more favorable than this. Since ito ay secondary. So, si electronegative ay kakabit kay carbon number 2 kasi si carbon number 2 ay isang secondary carbon. So, ito na yung ating regiospecific compound. And I would name this as propanol. So, that's Markovnikov's rule explained.